Hello, precious friends. Hope I find you well today. Okay. Today is a very simple day. We are going to be looking at a topic called the laws of indices, usually known as exponents. Okay. So, if you're new to this channel, I advise you to do the right thing. Simply subscribe and be part of the family. Okay. So that whenever I upload content here, you get it while it's still fresh. Okay, do not also forget, if you have subscribed, to click that bell button so that you can also get notifications whenever I upload the content. Okay, so what I want to do here at the moment is to start by introducing the nature of an exponent. That's what does an exponent look like. Okay, so exponents, they have got this form: n to the power of p, okay, whereby n is what you call the number, and then p is what you call the power. Okay, so what happens here is the nature of the laws of indices has led also to what you call, okay, the nature of an index or a number in index form is led to what you call the laws of indices, which is the laws of operation. Laws of operation is to do with how do we multiply them and how do we divide them, how do we add them or subtract them. That's what you call the laws. So what I want to do here at the moment is I just want to show you by an example. If we have anything that has a number, for example 3, okay, sorry for that. For example, we have a 3 to the power of 5. Okay, this is an exponent because it consists of a power and a number. Okay, meaning to say it is made up of a power and a number. Let us look at how does this affect what you call, operations. So the first and foremost thing I want to do is to consider what you call multiplication and division of numbers. Okay, so meaning to say we want to multiply numbers and we want to divide numbers. So this leads to what you call law number 1 and law number 2 of indices. When numbers are the same and multiplying each other, the law states that we add the powers. Meaning to say, if we have any number to the power p that's multiplying the same number to the power of q, then your answer definitely should be that number with its powers added. And that's the first law. Okay, that's what you call the first law. And then we consider the second law. The second law is the other side of law number 1, where we have n in number, that's n, and then to the power of p. Instead of multiplication, we are saying we are on side b, that's division, and then n to the power of q is equals to, okay, so the law, instead of adding, it subtracts. So it is very simple if you want to understand this. The thing is, whenever you have multiplying numbers, you add the powers. When you have dividing numbers, you subtract the powers. Those are the first two laws of indices. Let us consider then also the other two, whereby you're multiplying and dividing. Automatically the component that we haven't multiplied or divided at the moment is the power, because we have done the first two was multiplying and dividing the number. Now we need to consider how do we also multiply and divide the power. Okay, that's fine. Let us consider that. Okay, so when we are multiplying and dividing the power, there is some rules, okay? So let us say, okay, we are now multiplying and dividing p, the power. This leads us to certain laws also, okay? So law number 3 and law number 4, that's what they are based on. So meaning to say you have any number to the power of p, multiplying a bracket means multiplying q, okay? So meaning to say the number is 1, there is no second number for you to multiply with. It's only one number, but it has got two powers which are multiplying one another there, okay? So the law states that if you have this case, what you do is very simple. You continue with the multiplication, meaning to say your answer becomes that number to the power of p multiplied by q, okay? And then we move on to a certain number raised to a power or to powers that are dividing. So the powers are dividing. Power p is divided by power q, okay? So what you do here is this symbol. The law states that the denominator becomes part of the square root, okay? So you introduce a square root and the denominator q becomes part of the square root, and the numerator remains, remains the power, okay? So let me repeat this again, okay? Let me just rub it. You introduce a square root, then the denominator becomes part of the square root, and then the numerator remains the power. Very simple, okay? So now, as I'll be refreshing your mind, let me just summarize. We have learned how many laws? We have learned about 4 laws at the moment, 4 laws of indices, of which of those 4 laws of indices, the first 2 were dealing with multiplication and division of the number part of an index. The second 2 were dealing with multiplication and division of the power part of an index, okay? When we are multiplying numbers and we find that they are same, then we add the powers, you see? And then when we are dividing same numbers, we subtract the powers. When we are multiplying the powers, we will continue with the process of multiplication on the powers. When the powers are dividing one another, you introduce square root, then denominator becomes part of the square root, and then numerator remains the power of the square root. It's very simple, okay? Alright, now let us consider the remaining laws, okay? So the remaining laws here are what you call conversion laws, okay? So meaning to say they are based on converting certain principles. So what I want to do is this. We want to talk about converting the format, okay, the format of any index. Format. Okay, all right. So when you're converting the format here, what you're going to do is very simple. We might be converting the format usually where the power is less than or is equals to 0. Meaning to say here, we want to change the format of the index from indices to numbers. That's very simple. When the powers are less than or equal to 0, you are advised to make sure that you express them not in index form but in a number form. Okay, so meaning to say we are going to have 2 laws. The first one dealing with powers equals to 0, and then the second one powers less than 0, because less than or equal to 0 means we have powers equal to 0 or powers less than 0. Let's get into it. So what you're going to do here is the first law deals with powers equals to 0. P is equals to 0, and the second one deals with P is less than 0. Okay, and in the case of powers being equal to 0, what you do is very simple. The law states that as long as the power is 0, any number to power 0 is equivalent to 1. Okay, that's very simple. And then this means if I'm given 5,732,5 whatsoever, and they put power 0, I just put a 1 with 100% confidence there. The answer is 1. So there is no need for me to be using a calculator because the answer is 1. Okay, and then let's consider this other example. Now, when the power is less than 0. So when the power is less than 0, what you do is it means that the power is a negative. In other words, it means that the power is a negative. Okay, so this means what you need to do is to say, since the power is a negative, okay, it means that the number form becomes a fraction. Okay, the number form becomes a fraction. Okay. Becomes a fraction. So this means here, if you have something like let's say, okay, any number to the power of a negative power, we say that the number form becomes a fraction, meaning to say your answer here now will do this. It will take the number and the power, you see, and make them a denominator. Okay, what did it do exactly? It excluded the negative power. So meaning to say you write n to the power p, positive, okay, and then you just make it a fraction by saying 1 over n to the power p. As simple as that. Okay, so this is a very, very simple concept. Okay, let us consider maybe when you're given 300, okay, let me just make it 3, okay, to the power negative 6. Your answer here becomes 3 to the power 6 under 1. Okay, so this means here this other part is just put in order for us to complete the fact that we must be having a fraction. I hope you did understood all these concepts. Okay, now let me just refresh your mind by summarizing them. Okay, so okay, as we said, we have 6 laws, okay, of indices, whereby law number 1 is n to the power p multiplied by n to the power q, there is addition. N to the power p divided by n to the power q, there is subtraction of powers. N to the power p multiplied by q, there is multiplication of powers. N to the power p divided by q, the denominator becomes part of the square root, while the numerator remains the power. Okay, and then we go on, we have the change of format rules, which are forming part of law number 5, okay, and law number 6. It says that any number to the power of 0 is 1, and then the number form becomes a fraction if the number is a negative. Okay, if it is a negative. Okay, that's very fine. Let me just give you a few questions and then we'll come to the end of this lesson. Okay, so here I have question 1 to 7. I just want you to pause the video at the moment, try them, and then resume them with me. Let us pause the video at the moment. Okay, I believe that you have done them from 1 to 7. So what you need to do is to look at them now as a family. Okay, so what I'm going to do here is to consider the first question, question 1. Okay, so what I'm going to do is I'm going to be putting these values into my calculator. If possibly I can do that. So what I want to do here is for question 1 we don't need to use much of a calculator. Let us just look at that. Okay, so question 1 is saying 3 to the power x multiplied by 3 to the power of 5. So what we are going to do is we see that these are same numbers, you see, multiplying each other. So this means we are going to add powers, and you have 3 to the power of 2 plus 5. Okay, and then what is going to be the answer? It follows 3 to the power of 7. Now we need to use the calculator. So what you need to do is to put 3 and then press the power button, put 7. Okay, and then you say equals, you get 2187. So the answer becomes 2187. Okay, we go to number 2, which is saying 4 to the power 7 divided by 4 to the power 5. The law of subtraction comes in, which is 4 to the power of 7 minus 5. Okay, and then what do we get? We get 4 to the power of 2, and the answer is 16. Okay, you can even put it into your calculator. 4 to the power of 2, and then you get 16. Okay, now we go to the next question. 4 to the power of 2 times 3, and then your answer becomes 4 to the power of 6, and then it's a big number, we have to put it into the calculator again. So you put 4, the power button, and then 6, you get your answer, 4096. 4096. Okay, and then we go to the next question, number 4. 25 to the power of a fraction, which is the powers are dividing themselves. The law states that you introduce a square root, you put your 25 inside here, the denominator becomes part of the square root, and then the numerator remains the power. Once you are done, okay, sorry, I'm putting a P there, it should be the numerator, which is 3. Okay, so this means what we are going to have is, what is the second root of 25? There's a simpler way of doing this. What you need to do is to use the shift button, and then it must show S on your calculator, and then you go to the power side, and then you have this thing. So you put 2, and then you go the next button, and then you hit 25. After 25, you go to the next button. For you to be out of the square root sign, then you put a power of 3, and then you say equals. You see the answer comes here, 125. So it will be sorted by your calculator. Okay, and then we go to this one. This one you just answer with confidence. The answer is 1. Any number to the power of 0 is 1. Then this one becomes a fraction where you are taking all the numbers and putting them and combining them. So your answer becomes 7 to the power 4 being the denominator of 1. Okay, so the answer becomes 1 over 7 to the power 4, which is equals to 1 over, what is 7 to the power 4? Use the same pattern, 7, and then oh sorry, I made a mistake, 7, and then you go to the next pattern, and then you put power, saying power 4, and then you say equals 2401, so you put it 2401. Then the last part is saying 76 to the power of 1. You don't need the calculator. The reason why I put this one is I didn't include it on the laws, but it is far necessary for you to know also what it means. Okay, so this law is saying that any number to power 1 is itself. Okay, so I've seen many students confusing these two laws. Okay, law number 5 and the 7th one, they just confuse them because they don't understand. Put it in mind always that any number to power 0 becomes 1, but any number to power 1 is itself. That's what you need to know. Okay, so guys, I believe you have understood and managed the concepts of indices. This marks the end of our lesson. Okay, we'll meet again next time. Do not forget to be part of the family by simply clicking the subscribe button and also the notification button, so that whenever we give you content, guys, you get it while it's still fresh. I believe and hope that you did enjoy this lesson. Let's meet next time. Share the video so that also a friend can also benefit and just help support the the good work that we are doing in revisions. Okay, see you next time, guys. Sharp.